August 9th. Ichen Jobai Sishiwu. A quiet morning over the city of Nagasaki. The city had been through days of war, but that morning everything seemed almost normal. People stepped out into the streets. Workers began their shifts, and the market slowly became more crowded. There was no sign that anything unusual was about to happen. The sky was clear, no clouds, no warning. At an altitude of over 9 meters, a B-29 bomber moved silently. No one on the ground knew that it was carrying a device that had never been used in this way before. Not a conventional bomb, but something capable of releasing energy from matter itself. At exactly 11, 2 inches in the morning, a flash appeared, brighter than the sun. And in that brief moment, physics revealed its true power. Not from tons of explosives, but from an amount of matter so small it was almost impossible to imagine. Only about 0. 7 grams, a tiny fraction of mass, disappeared. And in return, an enormous amount of energy was released. Enough to change an entire city in just seconds. But what makes this story so hard to believe is not the explosion. It is that number. How could just 7 grams of matter destroy an entire city like Nagasaki? That number does not feel real because your brain was never designed to understand it. When you hear 7 grams, you think of something light, something trivial, something that can be ignored without consequence. It is less than the weight of a paperclip, less than a pinch of sugar, something you would not even notice if it disappeared. And yet, in this case, that small amount is connected to an event that erased buildings, shattered structures, and changed the lives of tens of thousands of people in a matter of seconds. The gap between those two ideas is so large that the mind rejects it immediately. It feels like a mistake, or an exaggeration, or a simplification that hides the real truth. But the truth is not hidden. It is simply outside of what we are used to understanding. The problem begins with how we intuitively think about energy. In everyday life, energy always feels proportional to size. A small fire gives off a small amount of heat. A large explosion requires a large amount of fuel. And if you want more power, you assume you need more material. This mental model works perfectly in the world of chemistry, where energy comes from breaking and forming bonds between atoms. But what happened in Nagasaki was not chemical. It was nuclear. And that difference changes everything. Chemical reactions involve the outer structure of atoms, the electrons, the bonds that hold molecules together. Nuclear reactions go much deeper, into the nucleus itself, where the forces are stronger, denser, and far more energetic. Inside every atom, there is an enormous amount of energy bound up in the forces that hold the nucleus together. You do not see it. You do not feel it. And under normal conditions, you cannot access it. That is why the world appears stable. That is why objects do not suddenly release energy for no reason. But stability is not the same as emptiness. It is more like a locked system, where the energy is present, but inaccessible unless very specific conditions are met. When those conditions are created, the rules you are familiar with no longer apply. This is why the number feels wrong, because you are unconsciously comparing it to the wrong type of energy. You are thinking in terms of gasoline, explosives, fire, things that require mass in large quantities to produce noticeable effects. But nuclear energy does not scale the same way. It is not about how much material you have. It is about how much of the internal structure of that material you can disrupt. A tiny change at the nuclear level can release more energy than a massive chemical reaction, simply because the energy density inside the nucleus is so much higher. There is also another layer to the confusion, and it comes from how we interpret the idea of mass itself. We tend to think of mass as something solid, something fixed, something that just sits there and takes up space. But in modern physics, mass is not just matter in the simple sense. It is a form of stored energy. What you are looking at when you see an object is not just substance, but energy in a stable configuration. That stability creates the illusion that mass and energy are separate things, when in reality they are two forms of the same underlying quantity. So when you hear that zero, 7 grams of matter were converted into energy. What you are really hearing is that a tiny fraction of a much larger energy reservoir was released. The number feels small only because you are measuring the mass, not the energy it represents. If you could directly perceive energy instead of mass, the situation would look completely different. That same zero, 7 grams, would not feel insignificant at all. It would feel overwhelmingly large, almost incomprehensible in scale. And this is where the intuition breaks down completely. Because once you accept that mass is energy, and that even a small amount of mass contains an enormous amount of it, the question shifts. It is no longer surprising that 7 grams could produce such destruction. What becomes surprising is that the world does not constantly explode around us. The only reason it does not is because the conditions required to unlock that energy are extremely rare and highly controlled. Without those conditions, the energy remains trapped, hidden in plain sight, inside every atom around you. So the number feels wrong, not because it is incorrect, but because it exposes a deeper truth about reality that we are not used to thinking about. It forces you to confront the idea that the objects you see every day are not just passive pieces of matter, but concentrated forms of energy, held together by forces that you rarely consider. And once you begin to see it that way, the story of Nagasaki stops being about a bomb and starts becoming about something much more fundamental. It becomes a story about what matter really is and what happens when you finally find a way to break it open. There is a reason one simple equation keeps appearing whenever we try to understand events like this, because it changes the way you see reality at the most fundamental level. E equals mc squared. At first glance, it looks harmless, almost too simple to carry any real weight. But hidden inside that equation is the explanation for why 7 grams of matter can produce destruction on the scale of an entire city. The key is not just that mass can become energy. It is how much energy is contained in even the smallest amount of mass. The speed of light, c, is an enormous number, about 300 million meters per second. And when you square that number, it becomes almost unimaginably large. That means every unit of mass is multiplied by a factor so big that the result no longer fits into everyday intuition. When you apply this to something like 7 grams, the result is not a small number at all. It is on the order of tens of trillions of joules of energy. To put that into perspective, without relying on abstract units, that amount of energy is comparable to the explosive force of tens of thousands of tons of TNT. In other words, something you'd normally ignore, something you would barely be able to feel in your hand, contains enough energy to reshape a city if it is fully released. This is not a trick of measurement or a coincidence. It is a direct consequence of how the universe is structured. Mass is not just matter. It is energy in a compressed and stable form. And E equals mc squared is the rule that connects the two. But the real shift is not in the numbers. It is in how you begin to interpret the world once you understand what the equation is telling you. Every object around you, every piece of matter, is holding on to an enormous amount of energy that is normally locked away. The reason you do not notice it is because that energy is not freely available. It is bound within the structure of the atom, stabilized by forces that prevent it from being released under ordinary conditions. That is why a table remains a table, why a rock remains a rock, and why the ground beneath your feet does not suddenly erupt with energy. Stability is the default state, but it is not the absence of energy. It is the containment of it. What Einstein's equation reveals is that the difference between a stable object and an explosive event is not the presence of energy, but access to it. The energy is always there. The only question is whether the conditions exist to unlock it. In chemical reactions, the energy you can access is limited because you are only rearranging electrons and breaking molecular bonds. In nuclear reactions, you are changing the structure of the nucleus itself, and that is where the scale of energy shifts dramatically. The forces inside the nucleus are so strong that even a small disruption can release energy on a scale that completely overwhelms anything you are familiar with in everyday life. This is why the equation changes everything. It removes the illusion that size determines power in a simple way. A large object is not necessarily powerful, and a small object is not necessarily weak. What matters is how much of the internal energy you can convert, and how quickly you can do it. In the case of Nagasaki, the process happened in a fraction of a second, which means the energy was not just large, it was released almost instantaneously. That is what transforms energy into destruction. It is not just the total amount, but the rate at which it is delivered. There is also a deeper implication that is harder to ignore once you see it. If mass and energy are interchangeable, then everything you see is part of the same system. The distinction between matter and energy is not as clear as it seems. What you perceive as solid and stable is simply energy that has taken on a particular form, held together by forces that keep it from changing. When those forces are disrupted, the form collapses, and the energy becomes visible in a way that is impossible to ignore. Light, heat, pressure, radiation, all of it is just different expressions of the same underlying reality. So when people say that 7 grams of matter were converted into energy, what they are really saying is that a tiny portion of that hidden energy was finally released. Not all of it, not even close. Just enough to demonstrate what the equation predicts. And once you understand that, the number stops being surprising in the way it was before. It becomes something else entirely. It becomes evidence. Evidence that the universe stores immense energy in the smallest places, and that under the right conditions, even the smallest amount of matter can reveal just how much power has been there all along. If you stop at the equation, you might think the story is simple. A small amount of mass turns into a huge amount of energy, and that is what destroys a city. But that is not what actually happened. The real story is more subtle, and in a way, more surprising, because the bomb that exploded over Nagasaki was not even close to being efficient. In fact, most of the material inside it did not contribute to the explosion at all. This is the detail that almost everyone misses, and it changes how you understand that number. Lean, 7 grams. The device dropped on Nagasaki, known as Fat Man, used plutonium-239 as its core. The idea was to create a rapid chain reaction where atomic nuclei would split, releasing energy and more neutrons that would continue the process. But for that chain reaction to work, the material has to reach a very specific condition called criticality. The atoms must be close enough together, and the reaction must happen fast enough that neutrons keep triggering new fissions before they escape. If the timing is off or the configuration is imperfect, the reaction stops prematurely, and most of the material never participates. That is exactly what happens in a real nuclear weapon. Even with precise engineering, the system is incredibly difficult to control perfectly. The reaction begins. Energy is released. The core heats up and expands. And as it expands, the conditions that sustain the reaction start to break down. The system essentially tears itself apart before all the fuel can be used. This means the explosion is self-limiting. It cannot consume all the material because the very energy it produces disrupts the conditions needed to continue the reaction. As a result, only a small fraction of the plutonium in the bomb actually undergoes fission. Estimates suggest that in the Nagasaki explosion, roughly 1 to 2% of the fissile material participated in the reaction. The rest was blown apart before it had the chance to split. And even within that small fraction, not all of the mass is converted directly into energy. The energy comes from the difference in mass between the original nucleus and the fragments it breaks into, a concept known as mass defect. This difference is tiny on a per-atom basis, but when multiplied across an enormous number of atoms, it becomes significant. When you add it all together, the total amount of mass that was actually converted into energy comes out to about 7 grams. Not kilograms, not even a large portion of the bomb, just a fraction of a gram. That is the true origin of the number. It is not the weight of the bomb. It is not the amount of plutonium inside it. It is the amount of mass that effectively disappeared and reappeared as energy during the reaction. This is where the story takes a turn that most people do not expect. Because if such a small amount of mass produced that level of destruction, then the immediate question is not how powerful the bomb was, but how much more powerful it could have been if the efficiency had been higher, if more of the material had undergone fission. The energy released would have increased dramatically. The limiting factor is not the total energy available in the material, but how effectively you can access it before the system disrupts itself. So the 7 grams is not just a measure of what happened, it is also a reflection of the limitations of the technology. It tells you that even one of the most destructive weapons ever used only tapped into a tiny portion of the energy stored in its own material. The vast majority of that energy remained locked away, never released, never seen. In that sense, the explosion over Nagasaki was not the full expression of what was possible. It was only a partial glimpse. And that realization shifts the perspective once again, because now you are no longer looking at the event as an example of maximum power, but as an example of incomplete access. A system that tried to unlock energy and only succeeded in doing so partially, yet still produced devastation on a massive scale, which leads to a deeper and more unsettling understanding. If even a small inefficiency can still result in that level of destruction, then the true scale of energy hidden inside matter is far beyond what was demonstrated that day. To understand what really happened in that moment, you have to go far below what you can see, past the level of objects and structures, down to the level of atoms and the forces that hold them together. Inside the core of the bomb, The material was plutonium-239, an element with a nucleus that can be split under the right conditions, but it does not split on its own. It needs a trigger. That trigger comes in the form of a neutron, a tiny particle with no electric charge that can slip into the nucleus without being repelled. When a neutron strikes a plutonium nucleus, it can destabilize it. And in a fraction of a second, the nucleus breaks apart. This process is called fission. When the nucleus splits, it does not simply break into two pieces. It releases energy, and it also emits additional neutrons. Those newly released neutrons then move outward and can strike other plutonium nuclei nearby. If the conditions are right, those nuclei also split, releasing more energy and more neutrons. What you get is not a single reaction, but a chain reaction where each event triggers multiple new events, and the number of reactions grows extremely fast. It is not linear. It is exponential. 1 becomes 2. 2 becomes 4. 4 becomes 8. And in an incredibly short time, the number of fission events explodes. But for this to happen effectively, the material must be in a very specific state. The plutonium has to be compressed into a dense configuration so that neutrons are more likely to collide with other nuclei instead of escaping. In the Nagasaki bomb, this was achieved using an implosion design, where conventional explosives surrounding the core detonated in a carefully timed pattern, forcing the plutonium inward. This sudden compression increased the density of the material and pushed it into a supercritical state, where the chain reaction could sustain itself and grow rapidly. Once that state was reached, the reaction accelerated beyond control. Within less than a microsecond, an enormous number of nuclei began to split almost simultaneously. The energy released in each individual fission event is tiny on its own. But when you have trillions upon trillions of these events happening nearly at the same time, the total energy becomes immense. This energy first appears at the microscopic level as the kinetic energy of the fragments in the neutrons. But it quickly transfers into heat and radiation as those particles collide with surrounding material. As the energy builds, the temperature inside the core rises to millions of degrees. The material is no longer solid in any conventional sense. It becomes an extremely hot plasma. At the same time, the pressure increases dramatically. The core begins to push outward, driven by the energy being released inside it. But here is the critical detail. The reaction is happening so fast that most of the energy is released before the core has time to fully expand and shut the process down. This is why the explosion is so powerful. Because the energy is concentrated into an extremely short time interval. The chain reaction does not last long. It cannot. As the core expands, the density drops, and the conditions required for sustained fission begin to disappear. Neutrons start to escape instead of hitting new nuclei, and the reaction quickly dies out. But by the time that happens, the damage has already been done. A massive amount of energy has been released into a small region of space, and that energy has nowhere to go but outward. In that instant, what began as a series of events at the atomic scale transforms into a macroscopic explosion. The energy propagates as a shock wave, as intense heat, as radiation, all expanding outward at high speed. The process that started with a single neutron striking a single nucleus has, in less than a millionth of a second, escalated into an event capable of reshaping an entire city. This is what actually happened inside the bomb. Not a simple detonation, not a burning fuel, but a rapid, uncontrolled release of energy from the nuclei of atoms. driven by a chain reaction that amplified itself faster than anything in everyday experience. And when you trace it back to its origin, it all begins with something almost invisible, a single interaction at the smallest scale that grows step by step into something overwhelmingly large. Energy does not disappear. It transforms. And in this case, it transforms so fast that it has no choice but to explode outward. The moment the chain reaction releases its energy, that energy is concentrated into an incredibly small volume, far smaller than anything you would normally associate with an explosion. There is no time for it to spread out gradually, no time for the system to stabilize. Instead, everything happens almost at once. And that is what turns energy into destruction. It is not just the amount of energy that matters. It is how quickly it is released and how tightly it is confined at the start. At the center of the explosion, temperatures rise to several million degrees, hotter than the surface of the sun. Matter in that region does not remain solid, liquid, or even gas. It becomes plasma, a state where atoms are stripped apart and electrons move freely. This sudden rise in temperature creates an equally sudden rise in pressure. The surrounding air cannot absorb that energy smoothly. It is forced outward violently, creating a shock wave that moves faster than the speed of sound. This shock wave is not just strong, it is abrupt, a nearly instantaneous change in pressure that crushes structures before they have any chance to respond. Buildings are not designed to handle that kind of force. Walls collapse inward. Roofs are lifted and torn apart. Windows shatter into fragments that become projectiles. The force travels through streets and between structures, reflecting and amplifying in complex ways, turning the entire city into a network of pressure channels. It is not a single push. It is a rapidly expanding front of compressed air that continues to move outward, carrying energy with it and transferring that energy into everything it encounters. At the same time, a large portion of the energy is emitted as thermal radiation. This is not ordinary heat that you would feel from a fire. It is an intense burst of light and infrared radiation delivered in a fraction of a second. Surfaces exposed to this radiation can reach extremely high temperatures almost instantly. Materials ignite. Skin burns, and anything flammable can catch fire without direct contact with flames. The energy arrives so quickly that there is no gradual warming, only a sudden transition from normal conditions to extreme heat. There is also an intense flash of visible light, bright enough to cause temporary or even permanent blindness. For a brief moment, the brightness exceeds that of the sun, and shadows are sharply defined against surfaces, capturing the outlines of objects and people in a way that feels almost unreal. This is not just a visual effect. It is a consequence of a massive amount of energy being released in the form of electromagnetic radiation across a wide range of wavelengths. In addition to the blast and heat, there is ionizing radiation. High-energy particles and gamma rays emitted during the reaction. Some of this radiation is released immediately, while other effects persist as radioactive materials are dispersed into the environment. This adds another layer to the impact, one that is not always visible in the initial moment, but continues to affect the surroundings long after the explosion itself has passed. All of these effects are different expressions of the same underlying energy: the shock wave, the heat, the light, the radiation. They are not separate phenomena. They are the result of a single process: the rapid conversion of a small amount of mass into energy and the equally rapid distribution of that energy into the surrounding environment. The reason it feels so overwhelming is that everything happens at once. There is no sequence that the human mind can easily follow, no clear beginning and end. Only a sudden transition from normalcy to extreme conditions. And this is where the scale becomes clear. The destruction is not caused by a single mechanism, but by multiple forms of energy acting simultaneously, reinforcing each other and amplifying the overall effect. The blast weakens structures. The heat ignites, fires. The radiation damages at a microscopic level, and together they create a situation where recovery is not immediate or simple. It is not just an explosion. It is a complex interaction of energy with matter, unfolding in real time. When you step back and look at it this way, the idea that 7 grams of matter could produce such an outcome begins to make more sense, because you are no longer thinking about mass as something small and insignificant. You are thinking about energy as something that, once released, must go somewhere. It cannot vanish. It cannot be contained in that moment. It can only move outward, transforming everything in its path. And when that movement happens in a fraction of a second in a dense environment like a city, the result is not just visible, it is overwhelming. And now comes the part that feels even harder to accept. Because just when you think you understand where the energy came from, you realize how little of the material was actually used. The bomb that exploded over Nagasaki weighed thousands of kilograms. And yet the amount of mass that was truly converted into energy was only about 7 grams. That means more than 99. 999% of the mass was still there, unchanged in any meaningful sense. It was not transformed. It was not converted. It was simply scattered, heated, or broken apart, but it remained matter. The explosion was not the result of all the material being turned into energy. It was the result of a tiny fraction of it being accessed in the right way. This is where intuition fails again, because we tend to associate destruction with total consumption. When something is destroyed, we imagine it being used up, converted, or eliminated. But in this case, almost nothing was used up in that sense. The majority of the plutonium did not undergo fission. The majority of the bomb casing did not contribute to the energy release. And even within the portion that did react, only a small fraction of the mass difference actually became energy. The rest remained as fragments, as debris, as material that was violently displaced but not fundamentally transformed. The concept that explains this is called mass defect. When a nucleus splits, the combined mass of the resulting fragments is slightly less than the mass of the original nucleus. That tiny difference in mass is what becomes energy, according to E equals mc squared. But the key word here is tiny. On the scale of a single atom, the difference is almost unimaginably small. It is only when you multiply that difference across an enormous number of atoms that it adds up to something significant. Even then, the total mass that disappears is still less than a gram. So what you are really seeing in Nagasaki is not a massive conversion of matter into energy, but a highly selective extraction. A system that managed to access a small portion of the energy stored inside atomic nuclei and release it very quickly. The rest of the energy remains locked away, still present in the matter that did not participate in the reaction. This is why the number is so important, because it tells you not just how much energy was released, but how much was left behind. If you follow this logic to its conclusion, it leads to a realization that is difficult to ignore. If such a small fraction of mass can produce that level of destruction, then the total amount of energy contained in the original material must be vastly larger than what was actually released. In other words, the explosion you are observing is not the full capacity of the system. It is only a partial demonstration. The bomb did not reach its theoretical maximum. It reached a practical limit determined by how quickly the reaction could proceed before the system disrupted itself. This changes the way you think about the relationship between mass and energy. It is not just that mass can become energy. It is that most of that energy is normally inaccessible. The stability of matter is not because it lacks energy, but because the pathways to release that energy are restricted. Nuclear reactions provide one of the few ways to access it, and even then, they do so inefficiently. The process is constrained by timing, geometry, and the physical behavior of the material as it reacts and expands. There is also a psychological shift that comes with this understanding. The number 0, 7 grams, no longer feels like the total cause of the explosion. It feels like a glimpse into something much larger. It represents the portion of energy that was unlocked, not the total energy that exists. And once you see it that way, the scale of what remains hidden becomes more significant than what was actually released. The fact that more than 999% of the mass remained as matter suggests that the true energy content of that system is far beyond what was demonstrated in that moment. So the real shock is not just that a small amount of mass caused so much destruction. It is that almost all of the mass did not. The event is not an example of complete conversion. It is an example of partial access. A system that briefly opened a window into the energy stored within matter released a fraction of it, and then closed again as the reaction shut down. And that leaves you with a final perspective that is difficult to ignore. If this is what happens when you access a tiny fraction of that energy, what does it say about the energy that remains locked inside everything around you? In the end, the story is not really about a bomb, and it is not even about a city. It is about what matter truly is and how little of it we actually understand in our everyday lives. When you hear that 0, 7 grams of mass were converted into energy. It sounds like a technical detail, something specific to a single event in history. But the deeper truth is that this is not an exception. It is a demonstration of a rule that applies everywhere. Every object you see, every surface you touch, every part of your own body is made of matter that contains energy far beyond what you ever experience directly. The only difference is that most of the time, that energy remains locked, stable, and invisible. What Nagasaki revealed was not just destructive power. It revealed the structure of reality in a way that is difficult to ignore once you see it clearly. Matter is not solid in the simple sense we imagine. It is a form of energy held together by forces that maintain its stability. Those forces are incredibly effective, which is why the world appears consistent and predictable. But they are not absolute. Under the right conditions, they can be disrupted. And when they are, the energy that was hidden becomes visible in the most extreme way possible. This changes the meaning of scale. We tend to think that large effects require large causes, that something massive must be behind something powerful. But at the fundamental level, that is not always true. A small change in the right place, at the right scale, can produce effects that seem completely out of proportion. The reason is not that the effect is too large. It is that our intuition is based on experiences that do not include access to the deepest layers of physical reality. Once you reach those layers, the rules shift, and what seems impossible begins to make sense. There is also a kind of silence in this realization that is easy to overlook. The world around you does not constantly remind you of the energy it contains. It remains calm, is stable and predictable, allowing you to move through it without thinking about what lies beneath. But that calm is not emptiness. It is restraint. It is the result of forces balancing each other, keeping the energy contained. The fact that this balance exists is what makes everyday life possible. Without it, the world would not hold its shape for long. At the same time, knowing that this energy is always present adds a different layer to how you see reality. It means that the objects around you are not just passive. They are potential, not in the sense that they are about to explode, but in the sense that they are structured in a way that could release enormous energy under the right conditions. That potential is usually inaccessible, and that is what keeps the world stable. But it is always there, built into the fabric of matter itself. So when you return to that number, lean, 7 grams, it no longer feels like a strange anomaly. It feels like a small window into something much larger. It represents a moment when a tiny fraction of that hidden energy was allowed to emerge, not because it was unique, but because the conditions made it possible. And once you understand that, the focus shifts away from the event itself and toward the underlying principle. The bomb did not create energy. It revealed it. It exposed something that is normally concealed, something that exists everywhere but rarely becomes visible. And that leads to a final understanding that is both simple and difficult to fully accept. The power that destroyed Nagasaki was not imported from somewhere else. It was already there, inside the matter itself, waiting for a way to be released. The event was not about adding energy to the system. It was about unlocking what was already present. And if that is true, then the world you see every day is not just a collection of stable objects. It is a vast network of stored energy, held in place by the laws of physics, quiet, contained, and almost completely hidden from view. So the real question is no longer how 7 grams of matter could destroy a city. The real question is how much energy is silently stored in everything around you, and what it would take to ever see it again.